and they will come approach, only works when you go to baseball diamonds. Okay, doesn't work for researchers. So we're starting to do some archiving using portal tools. We've got a suite of tools we've built, one called Grizzly, which is a generic portal tool that's in pretty wide use. If people use portals, you can capture everything you need. That may change with the shift to Web 2.0. We're finding more and more uptake of web services, web solutions, whether it's in industry or in academia. People love to just do things on the web and not have to install something. Right? And web-based tools, or of course Microsoft will tell you that Microsoft HPC cluster is going to win out, and we have some people that are bound and determined to use that. Except if you've tried it, the file system performance is really absolutely horrible, so we're going to get them to pull the plug on that pretty soon. Archiving of virtual memory, VMs. People have said a lot about cloud computing, so we're looking about being able to archive VMs. That's a very efficient solution because it enables you to solve the problem of what software stack was used to build things. That's coming along. I think you'll see more and more in that domain happening. Again, that's cloud computing. And modified shells as well. I think saving VMs is going to be a lot easier. Okay, so I want to talk now a little bit about research opportunities and challenges. How long have I been going for here? Oh, half an hour, that's good. I don't intend to talk for more than an hour, but we should have lots of time for questions. And obviously, I'll be around tonight and tomorrow morning if people want to grab me. Okay, so this is what the architecture looks like, essentially. Typically, what the universities do is they have their own local storage. We use gateway machines. These are just VM stacks, which enable you to talk through the VM stacks, multiple of them running on the gateway machines to the university machines. Then we move it back to a central data fabric that we control. And that's operated by us on behalf of the national consortium. Right? The national consortium is what's called a joint venture between all of the state partners in advanced computing. So it's not an independent company. It's simply a confederation of the different state institutions. Then that can move off to the interstate or overseas connections. If people want higher reliability, if they don't trust what's going to happen in Victoria, we can move the data across to another state, save it there, or move it closer to users. Again, this is all being designed around the large sources of data. For example, in Western Australia, they're putting in an SKA prototype. They're putting a large supercomputer there. That's got a very large data archive located there. Okay. A couple other things. Authorization and authentication is a problem in a lot of places. So we operated the Australian Certificate Authority. Now we've ceded that over to ARCS, so we're part of that mechanism. The other nice thing is that there is actually, in Australian universities now, there's a single national login. If you go to any university in Australia and I log into what's called the Eduroam wireless network, it authenticates me back against my home institution and lets me log on. Now, that doesn't solve all problems. You still need certificate authorities in order to be able to manage user privileges, rights, and accesses. So what we're doing is we're using the national system there. We're enhancing with Shibboleth and various other things. So that's part of the ARCS development effort is, again, a national effort for national authorization that the universities have agreed to. So that's more or less under control. Although anyone that tells you that certificates are easy and painless and so on needs their head examined. So the other point, too, is that ARCS does more than just operate the grid. We do a lot of work for research collaboration tools. This is what's called extremely low-hanging fruit, or fruit that's rotting on the ground. We support, for example, Wiki, Plone, Sakai. But collaboration tools are very interesting. We support Access Grid and Evo. And one of the real problems, I guess people have seen it here, is that it's very hard to operate those type of tools. And sometimes you're better just blowing them up and just saying, well, just all use Skype, right? Okay, so we've already got Datagrid services in beta. We've got what's called a grid Dropbox is the best way of describing it. Essentially, if you're at any one of the universities, you can network mount this and just drag files and drop them. So that's one of the utility services that we're providing to people. If you need to transmit a large file to somebody, you don't have to attach it to email. and use, some sort of brain-dead piece of Outlook or something to get access to it, you can just drag and drop it onto a national Dropbox. So that's in beta right now. A number of useful tools. They're all on the ARC's website. So I'll talk a bit about research opportunities and challenges now. Security and privacy is a huge challenge. The problem is not going to go away. It's only going to get worse. The more you do data sharing, the more that you allow data to flow through the internet, the worse the problem's going to be. We had a problem recently where we started to leak medical data through a mailbox. We thought we had everything completely secure. We had networks that were locked down, everything that was locked down, but accidentally through Mailman, we made one of our mailboxes public, and then, whatever it is, Google goes and finds it, and then you've got medical data floating around. We're working in some ontology, discoverability, data curation. Now, many of these projects, too, are not just Australia-wide, they're international. One of the ones that we're doing the most work on is what's called the Human Variome Project. Give you some idea of the challenge of this if you haven't heard about it. The idea behind the Variome Project is to archive all of the known genetic differences between humans. You can imagine if that facility existed, the power of that facility. At the moment, what's happening is people are building local databases for genetic data on, for example, breast cancer. So I guess people are familiar with the fact that BRCA1, BRCA2 are indicators for this. There are now test labs, I'm sure, here in Canada, which actually do testing for this. But if you discover a different mutation in a testing lab, what do you tell somebody? In this case, those labs have got to go and do a great deal of work to search the internet to see, has anybody else seen this mutation before? And then you've got to know, what's the reported. So clearly the ability to share information about mutations is going to be one of the big trends coming down the track. There are already these testing services which, you give them $1,000, they test you for a whole bunch of mutations and give you a whole bunch of depressing results, right? So again, we're involved in a large project doing that. The pilots for that are going off. It's a big problem in terms of ontology, discoverability, curation. Who manages this data? How do you know that a piece of data which came from Yellowknife is as good as a piece of data that came from Edmonton, for example? Okay, data mining and visualization. We're doing a lot of work in that area at the moment. That's a big challenge for us. How do you provide access to viz facilities? And there's some productivity improvements there. We've found with medical instruments, whether they're electron microscopes, providing remote access to these, providing better visualization, gets something like 20% productivity in people's performance. Again, one of the points of cyber infrastructure, one is doing larger experiments, so the bigger chunks of data. The other selling point is simply making scientists more productive and giving better access to equipment. Finally, I'll go to a few lessons we've learnt over 9 years at VPAC. The first one, I think, is it has to be a partnership. It's all about collaboration. As soon as you get competition going, then it tends to be destructive. Everyone protects their own turf, their own data. It requires people to co-invest, whether it's a university level, a provincial level. One of my mottos is never do anything for free, because people only value what they pay for or they invest in, or what they're willing to put resources in. Leveraging is really important for us. What we do all the time is we get one pile of money and we leverage it to get some more money from somebody else. Then you go back to the original group that gave you the first pile of money and leverage some more out of them. And hopefully they haven't figured it out. It's sort of like a Ponzi scheme, only it's legal. Competition in service provision, we say, is not productive. You don't want multiple people trying to do it, mainly because the number of people who are actually experts in e-research and cyber infrastructure is so small that if you get conflicting advice and different groups, then you're in real trouble. The other one is we've finally managed to convince the federal government that people are infrastructure, right? People are the key resource. I can go out to IBM or SGI and I can